Hi students, next topic in third module is device file APIs. Okay, files are used to interface physical device with application programs. Okay, means they are telling that device files are used to interface physical device with application program, means to interconnect the physical device with the application program. Okay, a process with super user privileges to create a device file must call the mknode API. Means here we are going to use mknode API as a function. Okay, the user ID and group ID attributes of a device files are assigned in the same manner as for the regular files. Okay, they are telling that the user id and group id attributes of a device files are assigned in the same manner for regular files. Means regular files के ಯಾವ ಥರ user id group id attributes for the device file are assigned in the same manner as for the regular files also. Okay, when a process read or write to a device file, the kernel uses the major and minor device numbers of a file to select device driver function to carry out the actual data transfer. Okay, means when you are going to read or write to a device file, the kernel uses the major and minor device number of the file to select a device driver function to carry out the actual data transfer. Okay, device file support is implementation dependent. Okay, Unix system define the mknode API to create device file. Means here we are going to use function as mknode. Okay, the prototype of mknode is you are going to use two header files and it is the prototype. Okay, here you can observe that there are three arguments: path name, mode, device id. Okay, there are three arguments. First argument, path name, is the path name of the device file to be created. Okay, next, the second argument, node, specify the access permission for the owner, group and others. Okay, also s underscore fch, sorry, s underscore ifchr, s underscore blk means character file or a blacked file flag to be assigned to the file. Okay, the third argument, device id, contain the major and minor device numbers. Okay, here you can see that for the example, here mknode is the function where SCS15 is the file name. It is a flag. Okay, it is a flag, means up to here it is a second argument. Here s underscore f ifblk, nothing but black file. Next, it is the read write execution for the user, read write execution for the group, read write execution permission for the owner. Okay, means the second argument mode specify the access permission for the owner, group and others. Okay, we mentioned here. It is the third argument is major and minor device number. Okay, suppose it is this function is success, means mknode API returns 0, else it's going to return minus 1. Okay, this is device file APIs. Next, FIFO file API. We know that first in, first out. Okay, FIFO file API is nothing but first in, first out file APIs. Okay, first in, first out file are sometimes called named named as pipes. Okay, means the other name of the FIFO files are pipes. Okay, pipes can be used only between related processors when a common ancestors has created the pipe. Okay, creating a FIFO is similar to creating a file. Nothing but ನಾವು ಯಾವ ಥರ we are going to create the file, same way we are going to create the FIFO file. Okay, indeed the path name for a FIFO exists in the file system. The prototype of MK FIFO is, there are 3 header files. This is the prototype. Okay, int MK FIFO, there are 2 arguments. One is path name, another one is mode. We know that it is the name of the file, and second argument mode is nothing but read write access for the user group and others. Okay, here also it is pass means it going to return 0, otherwise it going to return minus 1. Okay, here it is the example. Here this is the name of the file, and this is the second argument from here to here. You can see that s underscore I FIFO means it going to indicate the FIFO file. Okay, here read write execute for the user means read write execution permission for the user, and only only read permission for the group and read permission for the others. Okay, this is the second argument permission. Okay, that is only they are telling here. The above statement create the FIFO file with read write execution permission for the users and only read permission for group and others. Means this represent the read write execution permission for the user, here read permission for group and read permission for the others. Okay, when we have created the FIFO using the MK FIFO, we open it using the open. Okay, indeed the normal file input output function like read write unlike etc all work with FIFO files. Okay, when a process open a FIFO file for reading, the kernel will block the process until there is another process that have opened the same file for the writing. Means ಫಸ್ಟು ನಾವು ರೀಡ್ ಮಾಡೋಕ್ಕೆ ಓಪನ್ ಮಾಡಿದ್ದೀವಿ ಅಂದರೆ FIFO ಫೈಲ್ನ, then the kernel will block the other process which is going for the writing the content to the FIFO file will be blocked until the read process is complete. Okay, similarly when process open a FIFO file write, the kernel will block the process until other process open the same FIFO for reading. Means when you are going to write to the FIFO, the kernel will go into black for the means kernel will block the purpose until other process open the same FIFO for reading, means only one purpose, for only one purpose the FIFO file will be open. If it is reading, the writing purpose is black. If we are writing, the reading purpose is black. Okay, this provide a mean for synchronization in order to undergo inter-process communication, means it going to help for the inter-process communication. In a particular process try to write something to FIFO file that is full, then the process will be blacked until other process has read data from the FIFO to make space for the process to write. Okay. What they are telling, suppose you are willing to write the content to the FIFO file, but you see it is full. Okay, means there is no space for the writing. ಆ ಸಮಯದಲ್ಲಿ ಏನಾಗುತ್ತೆ, then it going to allow for the process to read. ಓಕೆ, ಆ ರೀಡ್ ಆಗಿದ್ಮೇಲೆ ಅಲ್ಲಿ ಸ್ಪೇಸು we are going to get it. Okay, on that time it make the space for the process to write. ಓಕೆನಾ, means content full ಇದ್ದರೆ we cannot write, so it's going to allow for the reading the content. After reading there will be a space. After reading there will be a space in the file, and that time we can write. Okay, similarly if a process attempt to read data from a empty FIFO, suppose ಏನಾಗುತ್ತೆ, empty ಫೈಲ್ನ ರೀಡ್ ಪರ್ಪಸ್ ಆಗಿ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ರೆ the process will be blacked, means read process is blacked because there is no content to read. Okay, up to when you are going to black until other process write data to FIFO. Okay, means up to another process write data to FIFO ಅಲ್ಲಿವರೆಗೂ ಬ್ಲ್ಯಾಕ್ ಆಗಿರುತ್ತೆ. From any of the above condition, if the process does not want to get blacked, then we should specify underscore non-black in the open call to the FIFO file. For any of the above condition, if the process does not want to get blacked, means ಇದು ಆಟೋಮೆಟಿಕ್ಕಾಗಿ ಆಗುತ್ತೆ. ಈ ಥರ ಆಗಬಾರ್ದು ಅಂದರೆ we should use O underscore ನಾನ್ ಬ್ಲಾಕ್ ಅಂತ ಯೂಸ್ ಮಾಡಬೇಕು. ಓಕೆ, ಇಫ್ ದಿ ಡೇಟಾ ಈಸ್ ನಾಟ್ ರೀಡ್ ಫ್ರಮ್ ರೀಡ್ ರೈಟ್, ದೆನ್ ಓಪನ್ ರಿಟರ್ನ್ಸ್ -1 instead of processing getting the black. Okay, if a process write to a FIFO file that has no other process attached to it for read, the kernel will spend pipe signal to process to notify that it is a illegal operation. The other method to create FIFO file not exactly for inter-process communication is to use the pipe system call, means we can create the FIFO file using the pipe system call. How we can use here, it is prototype of a FIFO is hash include unistandard int pipe is the function where int file descriptor 2. If it is pass, it going to return 0, otherwise it going to return -1, means it is fail. If the pipe call execute successfully, then process can read from file descriptor 0 and write to file descriptor 1, means if it is pass, file descriptor 0 ನಲ್ಲಿ we can read the content, where file descriptor 1 ನಲ್ಲಿ we can write the content. A single process with a pipe is not very useful. Usually a present process use pipe to communicate with its children. Okay, this is FIFO file API. Last one is symbolic link API. Symbolic link is an indirect pointer to a file. Unlike the odd link which point directly to the inode of the file, means it is a indirect pointer to a file. Unlike the odd link which point directly to inode of the file, means one file irutte, odd link will going to point directly, where the symbolic link will going to point indirectly. That is symbolic link. Symbolic link are developed to get around the limitation of odd links. Symbolic link can link file across file system, means instead of odd links, why you are using symbolic links? These are the reason. First reason is symbolic link can link file across the file system. Symbolic link can link directory file. Symbolic link always refers the latest version of the file to which they link. Okay, anyone can create symbolic link to directory. Symbolic links are typically used to move a file or an entire directory hierarchy to some other location of the system. A symbolic link is created with the same link, means symbolic link can be created using same link function. Okay, here you can see that the prototype is, there are three header files: hash include, unistandard, hash include system or type.h, hash include system.state.h. Okay, here there are three functions. One is sam link, read link, l state. Okay, here in sam link the original link argument is there, and symbolic link argument is there. There are two arguments. Next, read link, there are here also there are two links. One is two arguments. One is symbolic link. Okay, and here there is a three argument: symbolic link and buffer, means it is temporary buffer which the content we are going to read, and what content the size is present here. Okay, next, l list, here also two argument. One is symbolic link and state v. What is the state? We are going to get it. Okay, here you can see that it is a example. The original link and symbolic link argument to a symbolic link call specify the original file path name and the symbolic link path name to be created. Here program to illustrate the symbolic link function, we used three header files: int main function, int argument count. This is the argument for the argument array. Okay, here buffer we mentioned 256 and t name, means temporary name also 256. Okay, we mentioned the size. Okay, if argument count is equal to 4, means you are going to create the symbolic link. If it is less than 4 means not equal to 4 means return link, that is you are going to create the hard link. Okay, this is going to represent the symbolic links using the some basic program. Okay, this is chapter 2 of module 3, that is unique process and process control. Introduction to processes. A process is a program under execution in the Unix or POSIX system. Process is nothing but program under execution in Unix. That is, we are going to call it as unique processes. Okay. In that main function, a C program start execution with the function called name. The prototype for the main function is int main. There are two arguments. One is argument count, another one is argument v pointer. Okay, means we know that any programs will going to start execution from the main function only, and we are going to get the prototype for the main function. It is the prototype where argument count is the number of command line argument, where argument v is an array of point to the argument. Okay, when a C program is executed by the kernel by one of the exe function, means they are telling when a C program is executed by the kernel by one of the exe function, means execution function, a special startup routine is called before the main function is called. Means special startup routine is called before the main function is called. Okay, the executable program will specify this routine as the starting address of the program. This is set up by the link editor when it is invoked by the C compiler. This startup routine takes value from the kernel, the command line argument and the environment and set things up so that the main function is called. Means before the main function we are going to call the special startup routine. Okay, what that will do, it going to read the command line argument and the environment and set things up so that main function is called. Okay, here in next slide I am going to show in the form of diagram how the program will going to execute. Okay, next process termination. There are 8 ways for a process to terminate. Means how we can end up the process. There are 8 types. First 5 are normal termination, that is return from main, calling, exit, calling underscore exit or underscore capital exit, return of the last thread from its start routine. This is first 5 is belongs to normal termination process, where the abnormal termination occurs in 3 ways, that is calling, abort, receipt of a signal, response of the last third to a cancellation request. Okay, here exit function. Okay, 3 function terminate a program normally. One is underscore exit and underscore capital exit, which return to the kernel immediately, and where normal exit will perform certain cleanup processing and then return to the kernel. Means they are telling that exit function, there are three types. One is underscore exit and underscore capital E exit. Another one is normal exit. This underscore exit will return to the kernel immediately, but normal exit will perform cleanup processing then return to kernel. Okay, means there is no sudden to not it going to, this normal exit will not return to kernel immediately. It going to perform some cleaning process and return to kernel then. Okay, here this is the prototype how we can use the exit function, means terminating program normally. Okay, all three execution function expect a single integer argument called the exit state, returning an integer value from the main function is equal to calling exit with the same value. These are exit 0. It is same as return to 0 from the main function. Means return to 0 we are using in C program same way. Here we are going to use it as exit 0. This both are same. In the following situation, the exit status of the process is undefined. Any of this function is called without an exit status. Main does not return without a return value. The main full of the head. Okay, that is if the exit state of the process is undefined. Okay, at exit function. Okay, with iOS C function in C program, a process can register up to 32 functions that are automatically called by exit. Means there are 32 functions that are automatically called by exit function. Okay, means they are telling that there are 32 functions that are automatically called by exit. These are called exit handlers and are registered by calling the at exit function. Okay, here hash include stdlib.h, this is the header, and int at exit void function void. Okay, it is going to return 0 if it is okay. It going to return non-zero value if there is a error. Okay, they are telling that if it is success, it going to return 0. If it is fail or error, it going to return minus, means non-zero numbers on errors. This declaration says that we pass the address of the function as the argument to at exit. Means this declaration says that we pass the address of the function, means here, okay, as the argument to at exit. When this function is called, this is not passed to any argument and it is not expected to return the value. Means when the function is called, means this function is called, it is not passed any arguments. Okay, it is not going to pass any argument and it is not expect to return a value also. The exit function call this function in reverse order of their registration. Each function is called as many times as it was registered. Here the below figure summarizes how C program is started and the various way it can be terminated. Okay, our execution will start. Okay, exe will call the functions. It's going to start from the kernel only. There are C startup routine. We already discussed special C startup routine, and it's going to main function. Means before main function we are going to call the C startup routine function. Okay, after function main function, user function is called nothing but other functions. Okay, user defined functions. Okay, it is called after call. It can be, this function can be terminated using underscore exit or underscore capital letter E exit. Okay, you can observe here. And other way also we can exit, that is normal exit, but it's going to clean up the normal it's going to perform cleanup processing, and then it's going to return to kernel. Okay, means the normal exit going to clean up some process, and it's going to exit function, and it going to return to kernel. Okay, exit function can have exit handler. Here you can see that, and standard input output cleanup function also is there. Means we know that the exit, normal exit, will going to perform some cleanup standard input output process. Okay, this is introduction to Unix processing. Here we discussed main function, how, and we also summarize how C program is started and the various way it can be terminated. Okay, thank you.